So hi and hello. Welcome to our channel named Illegal Exploration. My name is Sami and today we are going to start about heap. So heap are actually of many types. Binary heap, ternary heap, canary heap, Fibonacci heap and binomial heap. Now heap is nothing but a tree only with some properties. Let's start about heap. Heap is nothing but a almost or complete binary tree. Now if you don't know what is almost complete binary tree or a complete binary tree, I suggest that please watch the basics of binary lecture. I'll put that link in a description box. Now we are only dealing with a binary heap. Now binary heap are of two types, min heap and max heap. Okay, so when the root is always minimum, it is nothing but a min heap. Now in this tree you can see that the root or a parent node is always a minimum. 1 is a parent of 10 and 20, in which 1 is minimum. 10 is a parent of 100 and 200, in which 10 is minimum. Right? So this is nothing but a min heap. Now let's come here max heap. When the root is always maximum, it is max heap. So 200 having a children 10 and 20, in which 200 is maximum. 10 having a children 1 and 4, in which 10 is maximum. So this is a max heap. Actually, since we are dealing with tree can be constructed in linked list form, in a linked list format, but we will have a node, link of a left subtree, link of a right subtree. So in this we have a tree field. When tree is actually dense, this will take a lot of space. So due to this, we can construct a heap or a tree using array as well. So to store the elements in an array format, we have to simply store the elements in level wise. Right? So let's store it 100, then 10, then 20, then 1, 4, and then 3. Now in this way you can construct a heap in array as well. Now while constructing a heap, we have to consider two terms, parent index and child index, that we have to find. Now given a node, let's say second node, we have to find its parent node, and given a node 2, we have to find its child node. So how you can find it? The formula is actually, to find a parent node, it is I minus 1 by 2. For left child it is 2i plus 1, for right child it is 2i plus 2. Now given a tree, let's find the child node and the parent node. Now here we have to find the children of 0th node. So the formula is, for the left child it will be 2i plus 1, right? So the value of I is 2. So 2 into 0 plus 1, it is 1. For the right child, 2 into 0 plus 2, this will be 2. Now we got value 1 and 2. Now you can see that node 0 has children 1 and 2. Now let's go further. Here we have to find the children of node 1. So 2 into I, that is 1 plus 1, this will be 3. For the right child, 2 into 1 plus 2, this will be 4, right? So you can see that node 1 having a children 3 and 4. Now 2 into 2 plus 1, this will be 5. So node 2 has node 5 as left child. Now let's find the parent node, starting with index 1. The formula is I minus 1 by 2. So 1 minus 1 by 2, this will be 0. For node 2, 2 minus 1 by 2, this will be also 0. 2 minus 1 by 2, this will be 1 by 2. Taking the floor value, this will be 0. Right? So the parent of node 1 and 2 is actually 0. Now for node 3 and 4, 3 minus 1 by 2, this will be 1. 4 minus 1 by 2, this will be 1. So parent of 3 and 4 is actually 1. Now for 5 minus 1 divided by 2, this will be 2. So the parent of 5 is actually 2. Now in this way we can find the parent node and the child node. Now let's come here at the height of a tree. Here it says we have to find the number of edges from a root to the longest possible leaf. This is the root and the longest possible leaf are present at this level, right? So the number of edges will be 1, 2 and 3. So the height of this tree is actually 3. Now the root is here and the longest possible leaf are present at this level. So the number of edges will be 1 here and 2. So the height of this tree is 2. Okay, what will be the height of this tree? This is the root, and the longest possible leaf is at this level. So number of edges will be 1 and this will be 2. So height of this tree is actually 2. What about this one? Now you can see that here we have only one node and the number of edges are actually 0. Height of this tree is actually 0. Now this is our first question. Given a max heap in the form of array, we have to insert the element 200 at the max heap. Now we have to insert 200 into the max heap such that the max heap property should not get violated. So there are certain steps we have to consider. Now our first step is we have to insert the element at the last level, or you can say at the last cell. So this is the array format and this is the tree format. I'm going to show you simultaneously how you can solve this. So let's insert 200 at this last cell and this will be at last node. Right, now what we have to do, we have to compare that node with its parent, because parent should be maximum because it is a max heap. So let's compare 200 with its parent, that is 1. Now actually 1 is actually smaller than 200. So don't you think we have to swap it so that 1 will be a child of 200? So 1 will be here and 200 will be here. And here also we have to find the parent of node 7. So to find parent, the formula is I minus 1 by 2. Right. So this will be 3. Now go at the index 3. Now here 1 is present and we can see that the parent is actually minimum then child. So let's swap it. 200 will be here and 1 will be here. But this is not there because we can see that 200 is still maximum and its parent, that is 25. So again we have to swap it. 200 will be here and 25 will be here. Now let's come here. Now here actually I will be 3. Now we have to calculate its parent. This will be 3 minus 1 by 2. This will be 1. Now go at the first index. Now here 25 is present, which is smaller than 200. So swap it. 200 will be here and 25 will be here. Now again we have to compare to its parent. We have to go till the root. So 100 is actually smaller than 200. So swap it. So 200 will be here and 100 will be here. Here also we have to find the parent. The parent of 1 is actually 0. So go at array of 0 and compare. And we can see that it is actually smaller. So swap it. So 200 will be here and 100 will be here. In this way, we insert an element in a heap. Now let's see the pseudocode. Now I have named the function as insert. I will be a of length minus 1. Now using a while loop in which I should not be equals to 0, first thing we have to do is we have to calculate the parent. Now the formula is I minus 1 by 2. Now after that we have to check whether a of parent is lesser than a of I. If this is the case, then only we will swap it. After that, what we have to do, I should be equals to parent. And if this is not the case, then it simply means that the property will not violate, so we will break it. So here I have written it. Now what will be the time complexity of this pseudocode? We are swapping the elements in this format. So this is nothing but a height of a tree. So the height of a tree is nothing but log n. So the time complexity will be order of log n. Right. So in this way we insert an element in Max Heap. You can do some changes and you can insert an element in min heap as well. So thank you.